we break it up into bits of 3s. And we go 1, 2, 4, and we just repeat that 1, 2, 4. 1, 2, 4 if we had one. And here's the reason, by the way. In hexadecimal, what's the largest number in hex? Yeah. Okay, what's 8 and 4?
12.
And 2? 14. And 1. 15, which is the highest number in hexadecimal.
1, 1, 1, 1.
Yeah, 1, 1, 1, 1, 1. And same thing in octal. What's the highest number in octal? 7. 4 plus 2 plus 1. So that's why we break it down. And we'll continue this after the break.
Who invented this?
Late out in our numbering systems, though, the 4 we use are the octal, decimal, hexadecimal, and of course binary. Most of your calculators anymore will have these functions on them. I shouldn't say most. A lot of your scientific calculators will have on them. They'll have OCT, VIN, AGX, and DEC. And so that you can transfer from one to another.
I was in Santa Monica the weekend. I went to this place and I called you on the phone. You said there's no such thing as a calculator like that. Well, you told me it is. I've seen it. I mean, you got one.
Yeah.
But I asked the guy, I said, this friend probably told me you got one. He said, you got nothing. You know, the store.
See, this one here has, yeah.
Yeah, I've seen one you're talking about.
Yeah. So that has, can't quite get to it.
All right.
Anyway, look underneath, I think, the second rows of keys. There's hex, binary, and octal. It's a sub-function. It's, anyway, if you ask for a scientific calculator, it should,
What's the best price? I'm cheap, I'll be honest.
Yeah, no. The best price you can get is over at either Kmart or Target, about $9.95. It won't have this on it for $9.95. All right, it will have all the basic functions, but it won't have this. To get this, you're going to run maybe $25. All right, to someplace right under that. But to get just a good scientific calculator, and don't worry about these to begin with. Right? We work with them, but we're not going to beat us to death. Now that one you've got there is Radio Shack's programmable, and it's about 30 to 40. I don't remember. I buy it when I need it and use them. Anyhow, so these are the numbering systems we use. Again, whether we're in one or the other, it doesn't matter. The value is going to be the same. I mean, if I have that many golf balls, that's how many I have. I don't care whether you call it 2, 4. I don't care whether you call it 8 in decimal, whether you call it 10 in octal, you call it 8 in hexadecimal. All right, it's going to be the same amount, and that's what's important. All right, conversions. I don't have this as a handout, and I don't know why, but I don't. I need to make this up. But this is the easiest way to convert. Just make up a little chart, put your numerical values in for decimal. That's decimal. In hex. In decimal, you're doubling because the first column is always, its value is 1. And we're talking in a binary value, so each position is 2 times more than the one before. So it's 1, 2, 4, 6, 1, 2, 4, 6. 1, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, and right on down the line, as far as you want to take it, up to a trillion. In hex, hex works just a little different. We break it up into values of 4 digits, so that we have 1, 2, 4, and 8, because again, this adds up to 15, which is the highest value in it. It's the 16th digit, but the 15th, its value is 15. We break, in octal, we break them up into values of 3 bits each, because its value is 7. Now I can go back and forth between any of them that I choose. And again, you're going to find it's much easier to go to a binary number and then into any of the rest of them I want to go to. If I have a hex number, I can convert that to a binary number and then to a octal or a decimal number. If I have a decimal number, I can convert it to a binary number and then to any of the rest. So it's fairly straightforward and simple. I'm not saying you're going to understand this and grasp it right out, but it really is not that hard once you start working with this. Okay, let me put, let's do this. I'm going to put about 4 numbers up here, and we'll go ahead and just convert them. Just use a little, you're not going to try it, you're not going to turn it in, so just use a scratch piece of paper and do this one. Let's go with F3, 9, excuse me. All right, F39, convert it, and convert this to decimal to octal and binary, of course. Let's see. Base 10. There you go. Here's 4 sets of numbers. F39 in hexadecimal, 362 in decimal, 59 in octal, and 1101010101 in decimal. In binary. Got it up here, just can't get it down. Okay, try those, convert them out, spend a few minutes. And while you do that, I'm going to wrap up the end of this and we'll get it done. Again, the reason why we go through all this is because the computer works on ones and zeros, which is the machine language portion. In programming, though, the programming portion of it definitely is programmed primarily in the hex. However, using octal, they use a little bit of decimal, but not much, because trying to go from decimal is the real difficult. It just doesn't convert easily the other directions. You can go from octal to hex to binary real easy, back and forth between these three, but when you throw in the decimal, it just doesn't, it becomes sticky. The way, well, you saw when I tried to convert the 195 to a binary number, how you had to do it. It's not as readily easy. So think about these. Again, you're going to find in programming, they're always going to use hex. When we talk about memory locations, they will always be in hex. A lot of the error flags that you will find in the computers will be in hex numbers. They will display some number on the screen and therefore will give you a hex number for that display. And that's it.